All right. So recently, Hogsmeade has seen a proliferation of candy shops selling smoked toffee, which is a really nice thing. So we have a demand relationship, which represents the marginal benefits, the supply curve, which represents the marginal costs, and then we have a supply and demand system given to us by these equations here. So the first question we're asked is that the government is imposing a 2 galleon tax on the sale of smoked toffee. So this nice thing, and the government is trying to generate some revenue from it. So we're asked to use a graph and algebra to discuss the impact of the tax on the equilibrium quantity and price. We don't have to calculate welfare. So that's so we'll talk about the areas, but we don't have to actually do the geometry to calculate the areas. Okay, so first we'll plot the demand curve. So it starts at a vertical intercept of 20. We'll label the vertical axis as price, the horizontal axis as quantity, and then we have our demand curve. And then we also have our supply curve, and this just runs through the origin and looks something like this. All right, so we know that without intervention, we have an equilibrium, so where buyers and sellers do not wish to change their prices. This happens precisely where marginal cost is equal to marginal benefit. So this will be our Q star, and then on the horizontal axis, we have our P star. Okay, so then the way I like to set these questions up, I like to do the full graph first, and then we'll talk through what each one of the components means. Okay, so we're imposing, the Ministry of Magic is imposing a 2 galleon tax on this thing, which, so as the buyer walks into the store, they have to pay $2 or 2 galleons to the seller, to the government, and they pay a certain amount extra to the seller. So some of what the buyer's paying is going to the seller and some is going to the government. Okay, so the way we think about this visually is using a tax wedge. So we know the buyer's price, when we plug the price the buyer is paying into the demand curve, and we plug the price the seller is receiving into the supply curve. Those two things, just like in untaxed equilibrium, those two quantities should be equal. We still have a market clearing condition where the seller's quantity supplied, and the quantity demanded, the buyer's quantity, are equal. So we'll call this Q tax, and this is precisely where we've sort of slid the tax wedge, and it's gotten sort of stuck in between the supply curve and the demand curve. So we'll just set up our two prices. We have the price for the buyer, we have the price for the seller, and these must be different by exactly the amount of the tax. So this vertical distance needs to be exactly 2 galleons. That's what this tax wedge is representing for us. Okay, and then we're going to do welfare. So we'll just write out different areas. So we have A, B, C, D, E, and F. All right, so we have 6 different areas, and we're going to talk about welfare. All right, so the first thing maybe we'll do is go through and solve for our initial pre-tax equilibrium quantities. So we'll call this pre-tax. And here, all we have to do is, set our two prices equal to each other. We know the price for the seller must equal the price for the buyer. There's no tax. So everything the buyer is paying is going to the seller. So we set these two things equal to each other, and then we have 20 minus 1/2 Q. And I'm going to drop the subscript because we have market clearing, so the two quantities must be equal to each other. And then this thing's equal to QS, and we've dropped the subscript. So here we have, we have 20 is equal to 3/2Q. And then at this point, we just need to multiply both sides by 2/3. So we have 40/3. And so this is awfully nice. So we'll call this Q star. And then we can find the price, so P star, which is equal to 40/3. Because all we're doing is taking the quantity, plugging it into the supply curve. So we just run the quantity up until it hits either of the two curves, but clearly the supply curve is the easier one. And then we find what the price is. Okay, so I'll just maybe label these. All right, nice. So we found equilibrium price and quantity. The next thing we want to do is find the tax equilibrium price and quantity. And the way we do this is instead of setting the two prices equal to each other, like we did with pre-tax, when we have a tax, the prices actually aren't equal to each other. So this is post-tax. And what we're saying is the price for the buyer must be greater than the price for the seller. So we know on this side, we need one thing, we need something larger to make the price for the buyer greater than the price for the seller. So we're going to add the tax to this side. The buyer is paying both the seller and the government. Okay, so now we have this thing, but all of the rest of the steps are exactly the same as what we've done. So we take the supply curve, we plug it in for the buyer's price, so the marginal benefit or the willingness to pay. So we have 20 minus 1/2 Q. And again, I'm going to drop the subscript just like we did above. But in this case, we have a tax, but we're still encountering market clearing. Like if we had a shortage, we would change the price. If we had a surplus, we would also change the price. That same logic applies in this environment as well. It's just we've wedged the prices. The price the buyer pays is not the same as the price the seller receives. The only difference. Okay, so here, so on the seller side, we're going to plug in for PS using quantity. Again, we're dropping the subscript and add the 2. Okay, so nice. So this is the thing, and then we solve for Q. So this is on one side, we subtract 2 from both sides, so we have 18. And then we add the 2 Q's together. So this is 3/2Q. And then we solve. So Q is equal to 18 times 2/3. So we divide 18 by 3, and we multiply by 2, and that gives us 12. So we'll call this Q tau to be our tax equilibrium quantity. And then we take this, and then just as we always do, we take the quantity and plug it into the supply curve to get our seller's price, and then we plug it into the demand curve to get our buyer's price. I'm going to show you a trick though. So we're going to find the seller's price simply by, so the supply curve is so simple in this case. So this is just 12. So we've plugged this quantity into the supply curve to get our price for the seller. The price for the buyer, we could do it 2 ways. One of them is way easier, or slightly easier. We can take this quantity and plug it into the demand curve, and that would give us the price for the buyer in that way. So all we do is we take 12, plug it in here. It would be 20 minus 12 divided by 2, and that would be 14. Or we could just notice that the price for the buyer has to be 2 galleons greater than the price for the seller. So this thing is just 14, just 12 plus 2. Either way you do it, it will always come out to be the same, so long as we've done our math properly. All right, so this is all nice, but we also want to consider welfare. So what we're going to do is look at these welfare areas and think about how they've changed before and after we've applied the tax. All right, so before we've applied the tax, our consumer surplus, so pre-tax consumer surplus was equal to A plus B plus C. Is everything below the demand curve, above the price, and inside the number of things being bought. Producer surplus is equal to everything below the price, above the supply curve, and inside the number of things being bought. Being sold. So this is D plus E plus F. And those are the only two sort of relevant welfare measures in this case. And then post-tax, we have consumer surplus, which is everything below the price the buyer is paying, which is PB. So that's everything, above this line, below the demand curve, and inside the quantity bought, which is, in this case, the quantity, the equilibrium quantity post-tax. So that's Q tau. So that area comes out to be A. Producer surplus becomes everything below the seller's price, above the price, the supply curve, and inside the number of items actually being sold. So that comes out to be F in this case. Government revenue is the height of the tax. So we're imposing a tax, which is a vertical distance between the two prices. So it must be between these two lines. And then we're applying it to all of the things that are being bought and sold, which in this case is Q tau. So this is this vertical distance between these two lines all the way out to this vertical line. So that is a rectangle. So this is B plus D. And then deadweight loss, in this case, comes from the fact that there are things that we would like to sell, but we are not able to sell them because something is getting in our way. So in this case, consumer deadweight loss is equal to C plus E. Okay, so we can write a few other things about this, but I want to make one point about deadweight loss. So before we talk about question 2, question 1, what we're saying, deadweight loss is between the benefits to society of making these exchanges and the costs to society. So deadweight loss, in this case, comes from the fact that there are things we're missing out on, some benefits that we could have had, and we're not taking advantage of them. So this is sort of like we're saying there are extra benefits we're missing out on. And we can find them when there are exchanges that aren't taking place, where the marginal benefit is greater than the marginal cost. So here, marginal benefit is greater than the marginal cost. Okay, so we're not exchanging these things, even though the benefits exceed the costs. All right, so this is a pretty good description of what's going on in this side of the market. We could talk about, welfare transfers here. So, we have B going to the government. We have D going to the government, and then we have so this is being lost. This is being lost. D is being lost by producers. E is being lost by producers, but we're generating some government revenue, and then we're missing out on some consumer and producer surplus that we could have had, but because we're getting in the way of making the exchanges, then they don't happen. So that's our deadweight loss. Okay. So the second part of the question, or the second question, is about the effects on residents. So we have some public health insight telling us that, actually wood smoke in Hogsmeade is a health concern. So we have all this, this delicious candy that, requires burning wood smoke, but it's causing, lung issues. So we're asking about the impacts on our market. So to do this, we're going to set up a graph like we do. So this is clearly an externality. It's a cost per unit that's impacting society. It's impacting Hogsmeade and the health of the residents. But you don't have to pay it if you're buying smoked toffee. So this is a classic externality, a cost to society that's not being borne by the buyer or seller. So let's set up the demand curve. So we have our demand curve, which is also equal to the marginal benefit curve. And in this case, because the externality is an additional cost, we're going to take our supply curve. And I guess I should have drawn this going through the origin, but the supply curve represents the marginal cost curve. So this is what sellers are responding to. It's like their incentives, their costs of production. But in addition to the private costs of production, we also have some extra costs that are being borne by society that are not being covered by the sellers. So we have an additional, it's almost this is not a shift up in the supply curve, but you can think of it in similar ways. Like it's a curve that's higher by some constant amount. So here we have marginal social cost curve, and the difference between these two things is just the externality. Okay, and in this case, the externality is 2. We have our original equilibrium, which in this case, because we have an externality, I'm going to call this Q hat. And, we could have called this Q hat. We just didn't know that there were externalities when we started this question. So we called this Q star and P star because it was the socially efficient quantities. But in this case, because we now know that there are externalities, we're going to call this Q hat, which is not a star. It's not a Q star because it is not socially efficient. We use star to denote the socially efficient quantity. When we have no externalities, from the first welfare theorem of economics, we know that markets maximize welfare in the absence of externalities, and a few other conditions. But here, that's not happening because we have this externality. All right, so we have the externality. We have it as 2 galleons higher everywhere on the supply curve. And what we're trying to do is find the socially efficient quantity of smoked toffees and the deadweight loss associated with the wood smoke. And then we're asked, how does the socially efficient quantity compare to the tax equilibrium in Q1? Okay, so let's do this in red. So we want to find the quantity that corresponds with where marginal social cost is equal to marginal social benefit. And what I haven't written yet is that the marginal benefit curve is equal to the marginal social benefit curve. There are no positive externalities. So all of the benefits are being absorbed by the buyers, where some of the costs to society are being borne by those who are not selling. All right, so this thing is our socially efficient quantity. So we'll call this Q star. Okay. So before we do anything else, I just want to identify what the deadweight loss is in this environment. So we know we have the socially efficient quantity where these two things are equal. We have a Q hat, which is what the market is delivering. But at this quantity, at this last one, the costs are actually greater than the benefits. So if you're buying this last one, you're actually contributing to society a cost, which is represented by the MSC curve, which is greater than the benefits to you. So there are more costs associated with buying that thing than you have benefits. So that thing is actually has more costs than benefits. So even though we're engaging with it, we're exchanging that unit. And we can look at all of the things where the marginal social cost curve is greater than the marginal social benefit curve, where the marginal social costs are greater than the marginal social benefits. And those items, when we exchange them, produce more costs than there are benefits, even though we're exchanging them. So on this side, we have a deadweight loss coming from not exchanging things where the benefits exceed the costs. And on this side, we have a deadweight loss coming from exchanging things that are too costly to society. So this is our deadweight loss in this case. We're exchanging them, and they're too costly. All right, so we have two different sort of notions of externalities. We're exchanging these things, even though society would not want us to. And in this case, we're not exchanging these things, even though society would want us to. So this is where the marginal social cost is greater than the marginal social benefit. We are exchanging items that are too costly. Okay. So in this case, we're exchanging things that are too costly, and in this case, we're not exchanging things where the benefits exceed the costs. Okay, so maybe I'll just write this in. Exchanges the market engages in but which have a higher cost than benefit. Okay, it's sort of maybe a clumsy way of saying that these things are too costly. Where on this side, we can say these are exchanges the market engages in, but which have, the market does not engage in, but which have benefits greater than their costs. Okay, so these are two types of externalities. And what we're going to try to do is find this Q star. All right, and then maybe we'll calculate the deadweight loss as well. Okay, so this is a sort of a conceptual idea, and it's incredibly powerful and will be very helpful when we think about the next things. Okay, so let's calculate first off the Q star. So when we find the socially efficient, we're setting the marginal social cost equal to the marginal social benefit. And in this case, the marginal social benefit is just the demand curve. It's just how nice the thing is, how much people are willing to pay. So I've sort of flipped the sides here unintentionally. So on one side, we have 20 minus 1/2 Q. And then on the other side, we have the supply curve. So it's the marginal cost curve. So this is, we have QS. I'm going to drop the subscript. And then we have the externality. So we're adding the externality on top of the supply curve. So that gives us 2. And then we can solve this thing. So this is 3/2Q is equal to 18. And maybe you've seen that before. So this is Q is equal to 12. So this is our socially efficient quantity. And it turns out, look, that comes out to be exactly the same as the tax equilibrium quantity. With the tax equilibrium quantity, we've lowered the quantity by some amount by sort of wedging the prices. And in this case, we wish we could lower the quantity by some amount. We're producing too much, so maybe we should reduce it. Okay. So we can calculate the deadweight loss in this case as well. And there's a bit of a trick here. So maybe I'll do this in pink. We have a deadweight loss, which is the difference between Q star and Q hat. And then we need to find the vertical as just being 2. So it's the area, which is 1/2 times height times base. We have 1/2 times height, which in this case, we know exactly what that is. The difference between these 2 points, one on the marginal cost curve and one on the marginal social cost curve, is 2. And then the base is just the difference between Q star and Q hat. We've calculated Q hat to be 40/3. So this is 40/3 minus 12. And this just comes out to be 4/3. You can check my work, but that would be our deadweight loss in this case. Okay, so we've sort of 2 conceptions of deadweight loss, and a tax lowers the quantity. A negative externality produces at a quantity too high. So if you're noticing a pattern here, what if we were to impose a tax, which in this case is equal to 2? What if we were to impose a tax that's equal to the size of the externality? Could we fix the problem of externalities using a tax? The answer is yes, and that's what we call a corrective tax. And that's where we're going next. But the last thing I want to do is talk about the incidence of tax. We should have done this when we were working on this originally. But the incidence of tax is just, so it's like how much has the price for the buyer gone up? So it's the price for the buyer minus the original equilibrium price. So in this case, that's 14 minus 40/3. So it's this thing. And then the incidence of tax on the seller is just how much the price for the seller has gone down. So in this case, that's IS, which is, so we have 12, which we're taking off of 40/3. Okay, so that's the incidence of tax on the buyer. Some people call it something slightly different, like the burden of tax. But this is the terminology we'll use in this class. All right, so this is a pretty good description. We could, write out some sentences to make some further conclusions, but these are most of the parts. And I think we'll leave it here.